Did you know that wireless communication has been used in industrial applications for over 30 years? Yes, and some of the first applications were the wireless control of automated guided vehicles and warehouse cranes. Wireless technologies have become progressively widespread in industrial automation applications for solutions with system integrators, government agencies, and industrial companies. And over the last 10 years, radio technologies have become standardized, like wireless LAN and Bluetooth technology, and which have become leading technologies for industrial automation applications. A powerful advantage with wireless networks is that they can be deployed easily to transmit data to areas, eliminating the requirement to run expensive cable infrastructures. And in addition to location flexibility, wireless technologies offer real-time communication for applications such as with SCADA and RTU communications, high bandwidth for video transmission used for remote security, and offers a lower total cost of ownership. Have you ever wondered how information like text messages, pictures, videos, and voice moves between wireless connected phones, computers, laptops, and cameras? It's magical to most, but can be realized when we learn about the invisible force performing all the work called electromagnetism. Electromagnetism is the creation of a magnetic field from the movement of electrically charged particles or movement or interaction between electricity and magnetism, such as when a changing electric field generates a magnetic field, or with the inverse, when a changing magnetic field generates an electric field. The same force is used to transmit radio waves when alternating electric current flows, propagating the signal through internal wires into a transmitting antenna, which in turn makes electrons vibrate, producing radio waves. Essentially, the antenna radiates the alternating current as an electromagnetic wave. This is where wireless transmission starts. When the radio waves travel through the air at the speed of light, and when these waves reach the receiving antenna, they in turn make electrons vibrate within it, reproducing the same waveform generated by the transmitting radio. During the time at 1, electricity flows into the transmitting antenna and makes electrons vibrate up and down, creating radio waves. The radio waves begin to travel at 2 through the air at the speed of light, and when the waves reach the receiving antenna at 3, they make electrons vibrate inside it, and this in turn produces an electric current that recreates the original sound or data. The frequency, or alternating waveform, of the signal changes based on how fast the signal from the transmitter is output, creating waves with different frequencies. Various frequencies can be used for different purposes. We call a range of different frequencies a spectrum, and are divided into areas of specific usage, or bands. Frequency is about how many electromagnetic waves pass through a point of reference every second. This is measured by counting the peaks of each wave, which will be measured in units of hertz, or cycles per second. Wavelength is the distance measured between the two highest peaks in a wave. This distance is referred to as a period. Wavelengths could be smaller than the size of an atom, and longer than the diameter of the planet Earth. Within this electromagnetic band of different frequencies, radio waves have the longest wavelengths and the lowest frequencies, which allows them to travel the farthest. The different spectrum of bands allows FM and AM radio waves, cell phone signals, Wi-Fi signals, and a lot more to share the same space because they are grouped within specific frequency ranges. Some of the specific frequency bands you may be aware of are ELF, or extremely low frequency, with a frequency of 3 to 30 Hz and a wavelength of 105 to 104 kilometers. And VHF, or very high frequency, with a frequency of 30 to 300 megahertz and a wavelength of 10 to 1 meter. And UHF, or ultra-high frequency, with a frequency of 300 megahertz to 3 gigahertz and a wavelength of 1 meter to 10 centimeters. And just so you know, in the U.S., authorities like the Federal Communications Commission, or FCC, or the European Electronic Communications Committee, or ECC, are responsible for assigning frequency ranges for specific usage. An electromagnet signal does not go straight out to a receiver after being transmitted, but radiates the signal in multiple directions. Radio waves can reflect off buildings, they can bend on sharp edges, or even scatter on small objects, and still be able to reach the receiver. During the journey, waves radiated from multiple paths endure different types of attenuation or weakening and delay. The receiving antenna captures all the waves as a combined signal, and when the wave travels more than one route, it is called a multipath channel. This multipath generated combined signal, now distorted and mixed, must be decoded by the receiver to read the data generated. This is not easily accomplished since the received signal contains a lot of unwanted anomalies. So, to make the receiver's job easier, we add some additional steps before transmission. Before sending any data, the transmitting components perform the encoding. The encoding operation appends additional bits into the message, which makes the data recovery at the receiver much simpler. After the encoding, digital data are mapped onto symbols, then modulated by varying the signal amplitude, and then passed to the transmitting antenna. This concludes How Does Industrial Wireless Communication Work? Part 1 of 2. In the next part, we will discuss more about modulation, radio path loss, line of sight propagation, path profile engineering to help radio propagation. Be sure to download the RealPARS app. When you download the app, you'll be able to watch an entire free course on PLC hardware. Just like this video, the lessons are all high quality and also very easy to follow. By downloading the RealPARS app, you have access to a wealth of practical knowledge as an automation engineer right in your pocket, and you'll also receive new fresh out of the oven videos each and every week.